Welcome then to some videos on this mock paper solution. So let's do it. Okay, the front sheets, usual thing. All right. Remember then the formula pages on the inside front cover. I think we need probably this one here, the prisms volume, for one of the questions, but not much to look at there really. Let's get into the maths, is it? So first one, let me just so Maxim is doing a project on shipping. No probs. He draws his own conversion graph to convert between nautical miles. Yeah, I can see that. And miles. No probs. Done. What's 50 nautical miles converted into miles? Well, okay. So 50 nautical miles is here. And can we see that that is exactly halfway between 0 and 115? So basically, I'm going to half 115. I am to see what it's going to be. If you do that, then you will get 57.5. That was done, easy peasy. And then the next question, complete the following statement. 800 nautical miles is equal to blank miles. Okay, so there's a few ways you can do this, and then you notice 800 nautical miles is not on the scale. So I might just perhaps look at 100. If you look at 100 nautical miles, you can see that that is 115 miles. So 100 nautical miles is 115 miles, but I want 800 nautical miles. So if we see this now, just get rid of that taskbar, sorry, go away. 800 of them, well, I can just multiply by 8, can't I? All right, so see I times by 8 there. So I'll multiply by 8 here. And if you do 115 times 8, maybe with the box method, all right, then in the end, you will get, I think it's 920. 8 times 115, just trying to work it out in my head. Yeah, it's 920 nautical miles. So 920 miles. Okay, so there we go. You could have also found 200 and times it by 4, but you still get 920. Okay, next question. So Mr. and Mrs. Blank have 3 children, Valerie, Theo, and Anton. The family visited in Wales. Valerie and Theo are 14-year-old twins. Okay, so Valerie's 14 and Theo's 14. Anton is 2 years old. Okay. They visit a castle and gardens and use the entrance board. So the family decides to pay the standard charges to visit. Okay, so the standard charges. How much change will they get from £20? Show all your workings. Okay, well, there's 2 adults. So that will be 2 times £5.60, which is £11.20. Then there's 2 children between 3 and 16. So 2 children. So that's 2 times £2.30, which is £4.60. And obviously Anton's going as well, all right, but Anton is free of charge because he's under 3. So I'll just add these 2 up here, okay, to see what you get. If you add these up, then you're going to get £15.80. How much change will they get from £20? Well, they'll raise £20, take away £15.80. That's going to give you £4.20 change. Done. Okay. All right, so the next question. So Theo looks at the charges with a 10% contribution to improvements. Okay, so Theo is looking, Theo is looking now, I try and do it in blue without messing things up. Theo is looking here now, so bear that in mind. He says the adult charge with an extra 10% is not right, it's too high. By how much is it too high? Okay, so the adult charge with the extra 10%. Let me find that a minute. So the adult charge with 10% extra. Right, so it was £5.60 and now it's £6.40. So let me make a note of that. real quick. So it's £5.60, but it's going to £6.40. So this is supposed to have gone up by 10%. So let's see what it is. Let's see what that should be. So 10% of £5.60 is 56 pence, and £5.60 plus 56 pence. Can we see that's going to be £6.14? So that's where it should be. All right, so by how much is it too high? Well, £6.40. Take away £6.14 is, oh, sorry, hang on. This year, my fault, it should be £6.16. Sorry, that's a bit sloppy. So this you can see now, if you take these two away, all right, then that is going to be either £0.24 or 24 pence too high. And that's that one done. So this question 2C. The gardens at the castle cover an area of 714,000 meters squares. Water ponds cover 2/7 of the area of the gardens. Find the area covered by water ponds. Okay, so basically I'm after 2/7 of 714,000. Remember the shortcut for a fraction of a quantity? Divide by the bottom times by the top. Okay, so basically I think first things first, I'll do 714,000 divided by 7, which is a very easy calculation. You've got 1 there, none remainder 1, 2, and then 0, 0, 0. Then times by the top, so times it by 2, and 2 times 102,000 is going to be 204,000. Very, very easy. Okay, question 3 then. The table show all of the international results for Wales in 1984 and 1985. Yeah, I can see that. Geraint says on average the football team scored more goals per match in 85 than in 1984 on average. In checking the truth of his statement, why is it not helpful to think about the range of the number of goals scored per match? Well, because Geraint's thinking about the average year, and the range is not the average. The mean or the median are the averages, and the mean's probably the best bet here. So you can just say here, okay, that the range is not an average. Okay, next question then. So by thinking about the mean number of goals scored per match by Wales in each year, is this statement true? You must show calculations for each year. Right, well, let's think about the 1984 mean first of all then. Remember, to find the mean, you add up all the numbers and divide by how many numbers there are, okay? But we only care about the number of goals scored by Wales in each match. So if you flick back to the previous page, you'll see that I care about the following numbers: 1, 1, 1, 0, 0, 0, 0, and 2, because they are the Wales goals, okay? And they played 8. You can see they played 8 matches there, okay? So I'm going to work out 1 plus 1 plus 1 plus 4 noughts plus a 2, and there was 8 matches, so I divide by 8, and if you add the top up, you get 5 divided by 8. If you use the bus stop method, you get 0.625 goals per game. And similarly for 1985, if you look at the mean, again, you only cared only about the Wales goals, so I care about 1, 1, 3, 2, 1, and 0. Okay, and they only played 6 matches in 1985. Okay, so for this mean, I've got to add up 1 plus 1 plus 3 plus 2 plus 1 plus 0 and divide by 6. And this is 8 over 6. You can cancel this down to 4 over 3. And if you use the bus stop method, you get 1.3 recurring. So what did Geraint say then? Geraint said that they scored more goals per match in 85 than in 1984. Well, yeah, he is correct, because last time I checked, 1.3 beats 0.625. So you can just say that 1.3 recurring is more than 0.625. In fact, it's actually over double it. But you haven't got to say that here, okay? So give one reason why this method does not necessarily show the Wales team were better in 85 than 84. Well, there's lots of answers you could say here, all right? But the thing, isn't it, if you're playing football matches, really, it all depends on who you're playing. That's the way I see it, okay? I mean, they might have scored less goals in 1984, but they could have been playing better teams, couldn't they? All right? If you play better teams, you're going to find it harder going. So I just said, we don't know how good each opposing team was. That's my answer for that one anyway, okay? I'll just do a quick time check a minute. I've got plenty of time to do this, at least this next question. Okay, so 4A, towns of Aberglen, Bargwyn, Kylo and Derwin are on bus route 3. I can see that. The times buses take to travel are shown on the picture below. So, yep, 10 minutes, yeah, I see all that. 10 minutes here, 30 minutes here, 20 minutes there. The buses start at Aberglen. Okay, no worries. And they all go to Derwin. So they finish here. And here is the timetable. First bus leaves at 9 o'clock, then every 30 minutes after this time. Okay. At what time does the 9:13 bus from Aberglen arrive at Derwin? Okay, so 9:13 there. And altogether it takes 10 minutes, add 30 minutes, add 20 minutes. That's an hour altogether. That's 60 minutes. So that's going to be 10:13. Well, that was easy. Dilys arrives at the bus stop in Bargwyn at 9:30. Okay, so she gets here at 9:30. What time is the next bus? Okay, well, I mean, if you think about it now, we know that, say, for example, the 9:13 bus, all right, would take 10 minutes to get there. So the 9:13 bus would get here at 9:23, but that's before she arrives. Okay, so that's no good. All right. And then what that would go then at next 30 minutes would be 9:26. Okay, that would leave here. All right, and then it would take 10 minutes to get here. So that's 9:36. Yeah, she could catch that bus, couldn't she? Okay, see, 9:26 takes 10 minutes to get there. 9:36, she's already there. So I'm going to say 9:36 for this one. Well, hopefully I'm right. I haven't checked my answers, so I'm assuming it's going to be okay. Any more questions? Oh, there are. Same on the bus routes. Right, so from Grainsea, the number 6 bus runs to Windrup. Okay, so this is the number 6 bus here. And the number 7 bus runs this way. No problem at all. Here's the timetable. Right, first bus leaves at 10 on this route. Then every 20 minutes, no probs. On this one also leaves at 10 as well. Then every 45 minutes. So after 10 o'clock, when will the number 6 bus and number 7 bus leave Grainsea at the same time? Okay, so number 6 bus, number 7 bus. That leaves at 10. Then every 20 minutes. Okay, so next one will be 10:20. Then 10:40. Then 11 o'clock. Oh, so I spot the pattern here already. So I see this, basically this bus is going to leave, basically, see, it loops around. It's just going to go 20:40 hour, 20:40 hour. So obviously it carries on, doesn't it? Let me look at this number 7 bus a minute. So 10 o'clock, 10:45. What would be then? It'd be 11:30. Yep. And then 12:15. Still no match. But look, I go again. 13 o'clock, 1 p.m. This bus, this number 6 bus, is going to leave at 1 o'clock as well, isn't it? See, because it leaves every hour as well. So yeah, they're both going to leave the same time, aren't they? At 1 p.m. So I'll just say 1 p.m. Okay, and that works. Yeah, I just counted in 20s and 45 till you see a match. That's the first time they'll leave together. So question 5. So Lekhan's parents have complained they're paying too much towards his mobile phone bill each month. He decides to ask a number of students in school to see how much their parents or carers pay towards their mobile phone bills each month. He shows the results in the scatter diagram, and they include his own results. No props. Right, so his parents want to know the names of some of these students. The two 15-year-old students are Harriet and Larry. Larry is older than Harriet. No worries. So two 15-year-old students. All right, so I can only see two 15-year-olds here. See, like one person is bang on 15, and one person is 15 and a bit. So what did it say? Larry is older than Harriet, right? So this must be a Larry, and this must be Harriet. Okay. And Gwilym and Ali's parents both pay £27.50 a month. So £27.50 is here. So this one and this one. Alid is younger than Gwilym, so this is Alid. And this is Gwilym. No props. So where's the actual question then? Oh, it's over here. Right. So Larry's parents or carers pay blank pounds per month. Well, let's find Larry then, wherever she was. Here she is. And so you can see, can't we? They pay £20 for her. All right. And Harriet's parents pay 30. So 20 and 30, that is there. Okay, 20 and 30. And then, right, Gwilym is something years, months old, and Alid something years, months old. Okay, well, let's just find Gwilym and Alid then. Right, well, Gwilym, luckily for us, you can see Gwilym is exactly 16, and Alid seems to drop down exactly halfway between 13 and 14. So he's 13 and a half. So in months, that would be 13 years and 6 months, wouldn't it? Okay, so Gwilym was 16, wouldn't he? 0 months old. And Alid, it was 13 and a bit, wasn't he? Yeah, 13 and a half years. So that's 13 years and 6 months. So Lekhan's parents pay £32.50 a month. He's the youngest of the 3 students who receive £32.50 a month. How old is he? Right, well, let's find these £32.50 students then. Oh, they're all here, look. It is this one, and this one, and he's the youngest. So he is here. So if I drop down, hopefully this hits bang on 13. Yeah, it does. Okay, so this dude is bang on 13. Okay. Do you think his parents are right to complain they're paying too much per month? Use a scatter diagram. Well, it's hard to tell really, isn't it? Because I can't see a pattern here. This looks like there's no correlation at all. So this scatter graph tells me nothing, really. There's no correlation here. All right, so I'm going to say no. All right. And say there is no correlation. There's no correlation shown in the diagram. And that's that one done. Okay, next one then. Sam is making a large pot of cheese sauce for a party. Okay, you write conversions. If I see a conversion, I write as a function machine. So the ounce is abbreviated to OZ. Okay, 1 ounce is about 28 grams. So I know going this way, I times by 28. Going backwards, I would divide by 28. Okay, so that's that one. And then 1 pint. So 1 pint is about 568 milliliters. So this way times by 568 this way, divide by 568. Okay, right then, he wants to write the following recipe in grams and milliliters. All right, no, it's in ounces and pints at the moment. Using the conversions, complete the table below. Okay, so butter, first of all, right, 4 ounces of butter. He wants to get that into grams. Okay, so butter. So see, from ounces to grams, you multiply by 28. So 4 times 28, I believe to be 112. Okay, so 112 grams of butter. The flour, 3.5 ounces. Okay, so that's 3.5 times 28. So for this one, okay, I'll just do 3 times 28, which is 84. And then I add on half of 28, because 0.5 is a half, okay? Half of 28 is 14. So I would get 98 grams here for this one. All right, if you want to, you could do 35 times 28 and put the point back in, but I'm not going to bother. I got a quicker way. The milk, 3 pints of milk in milliliters. So times by 568. So 3 times 568. Okay, again, maybe you have to use a little box method here or a grid method, or you could write down 568, couldn't you? You could write it down 3 times. I mean, whichever method you use to get it. Okay, then you should end up getting 1,704. Oh, sorry, not grams, milliliters. Okay, so that's 1,704. And then the cheese, I gotta do 9 times 28 again. 9 times 28. So I'll do 10 times 28, which is 280, and take off 128, which is 252 grams. Okay, so if I just scroll down a tiny bit and write 252 there, all right, then I will be done. Question 7 then. So Macy and Gareth are planning the bike ride. They have a map with a scale of 1 to 50,000. Okay, so 1 to 50,000. If you don't know about map scales, okay, then this scale means that, for example, on the map, every 1 centimeter in reality would be 50,000 centimeters. Okay, that's what the scale means. The map is 50,000 times smaller than reality. Garrett suggests the route does 48 centimeters on the map. Okay, so 48 centimeters on the map. Okay. Macy says she could cycle up to 13 miles. Can she cycle the route? Right, well, this to me, this question looks like it's going to be about miles and kilometers. Somehow I've got to work out how much this would be, this 48 centimeters would be in reality, and try and compare it to some miles. Okay, so the trick here is to see, look, right, that here you times by 48. So here you'd also multiply by 48. Okay, and the I think the easy way to this really is to 5 times 48, which is 240, and then add on these 4 zeros, 1, 2, 3, 4. Right, now I'm trying to look at this in terms of miles. Remember, centimeters though are in the metric conversion chain, you know, centimeters, meters, kilometers. So I know that 1 meter is 100 centimeters. So hopefully you can see that if I'm going backwards this way, like I need to divide by 100. So I'll do 2, 4, and then 1, 2, 3, 4 divided by 100. And obviously you can just take off 2 zeros, your top and bottom. Okay, and you're left with 24,000. I know next then that 1 kilometer is 1,000 meters. So going backwards, I'm dividing by 1,000. So 24,000 divided by 1,000. Well, 1, 2, 1, 2. Oh, sorry, ignore that. Try to make a shape for me. Basically, I can cancel off 3 zeros, kind of top and bottom, and you're left with 24 kilometers. And the key thing is now, right, that 5 miles is about 8 kilometers. So if I got 24 kilometers, see, the multiplier here is 3. 8 times 3 is 24. So 5 times 3 is 15. So this route is 15 miles long, and Macy can only cycle 13 miles. So she can't cycle the route. Maybe a semicolon then. It is 2 miles too far. She can do 13. This route is 15. Okay, that's a tough question there. Lots of knowledge required. Okay, number 8. The base of Miss Morgan's new bungalow is shown below. All right, so if ever I see a shape like this, I'm not looking at the question in a minute. I see missing sides, and I'm going to work these out real quick because I'm probably going to need them. This side here, hopefully we can see that it needs to be 11 meters because all this here, see, all this is 15, and up to here is 4, and 4 add 11 is 15. And this one here, I think, will need to be 15 meters. Okay, here, because all the way across is 20, and up to here is 5. Yeah, 5 add 15 is 20. All right, where's the actual mass then? So the concrete base, oh, I see. So this base now has been folded, flipped down if you want, and it's 0.2 meters thick. Find the volume of the base, show what you're working. Okay, well, it may not look like it, all right, but this shape here actually is a prism because it has got a cross section. Okay, remember the flat bit you can see is the cross section. Okay, so this cross section is a shape here, and this prism is 0.2 meters high. Right, some people would say it's 0.2 meters long, but it's all the same to me. Okay, because we know, don't we, all right, that from the formula booklet on the inside front cover, a prism's volume, okay, is the area of the cross section times the length or the height. And this cross section, this is the cross section here, this bit, which really is this bit here, right? And it's this whole compound shape at the top, okay? All right, this shape here. So I need to work out the area of the cross section first of all, and I think I'll just split this into two different rectangles. All right, and I call them shape 1 and shape 2. Okay, work them out separately and add them both together. So I'll probably got a bit of space to do it here actually. So the area of 1 is going to be 4 times 5, which is 20 meter squares. Sorry, and the area of 2 is going to be 15 times 15. And if you know your square numbers like me, that's 225 meter squares. So you add those up now to get a total cross section, and you get that to be 245 meter squares. Okay, so the cross section is 245 meter squares. Remember, to get the volume now, let me just get that into focus, sorry. To get the volume, I have to do the cross section times the length or the height. Okay, so up to you, okay, you might want to do 245 times 2, then divide by 10. All right, but you know, whichever way you do this in the end, you're going to get 49. And because it's a volume, it'll be 49 meters cubed. Okay, and then with that we are done. Quick time check. Let me see what the next question is like then. What is this next question like? Oh, sorry. So yeah, I put the answer here again. If I just in case, 49 meters cubed. And I'll just do question B, and I'll stop on this one. So he's building a garage. Nice one. A concrete mixer holds a maximum load of 6 meters cubed. Okay, so you can get 6 meters cubed in here. And there's this delivery charge of £35 a load, and the concrete costs £45 per meter cubed. He orders 2/3 of the maximum load. What's his cost, right? So basically he orders 2/3 of the maximum load. So 2/3 of 6 meters cubed. If you work it out, 6 divided by 3 is 2. 2 times 2 is 4. Okay, so he orders 4 meters cubed of concrete. And the concrete costs £45 per cubic meter. So I'd have to do 4 times 45. So that's £180 for the concrete. But there's also a delivery charge of £35 a load. So I better add on 35 now for delivery. And if you work that out, you're going to get the answer 215. So the total cost is £215. Done. Okay. So question 9. Olga took out a high interest loan for £400. Cool, bad idea. She paid back £49 per month for 20 months to clear the loan. Find the interest she's paid as a percentage of the loan. Right. So remember, the interest means the extra amount you paid. So if she paid back £49 a month for 20 months, that is £980 she paid back. So I hope you can see now, okay? That means if you take off the original 400, she paid back £580 in interest, which is ridiculous. That's more than she took out. All right. Work out the interest she paid as a percentage of the loan. Okay, so out of the 400, she's paid back 580. And remember now, I want to work out as a percentage. So without the calculator, I need to make the denominator 100, which I'll do by dividing by 4. Okay. So either do it in your head, okay, or if you're not feeling that confident, then you can do this. You could halve it twice, or you could do, 1, remainder 1, 4, remainder 2, okay, and you get 145. So this actually is 145%. Nice, easy 4 marks there, as long as you know how to make a fraction into a percentage without a calculator. Okay, what's this then? Oh, blank page. Nice. Okay, so question 10 then. Sarah's carrying out a survey of 3 villages. Yeah, I can see that. And this shows the position of the 3 villages. I can see that. Right, what's the bearing of Althea from Gwyndir? Right, so remember the bearing is the angle measured clockwise from north. So from Gwyndir to Althea, that's my angle there. And I hope you can see this obviously going to be 190 degrees because in a full turn is 360. So I'll take off 170 and you will get that this here is 190. What's the bearing of Cwm from Althea? Well, okay, so I need this massive angle here. This one, okay, you're relying on parallel lines. See, these 2 north lines are parallel. So I'm thinking about, our corresponding angles, all right? I mean, the way I see it, you could do this a few ways, but I think maybe the easiest way to do it is if you extend this line here. Hopefully you can see that this angle here has got to be 28 to make a half turn, to make 180. And this angle here corresponds to that 28. So that's also 28. And then I only want the bit that I'm going to try and go over in blue, okay, without breaking my computer, which has just gone very slow. Hopefully it'll catch up. Give me a sec. Hopefully it'll catch up. Maybe I'll pause it and come back to it. Oh, I think it's come back. It has come back. Sorry. Here we go. So I'll try it in blue. I need this bit here, then this blue bit here. So I will just do 360. Take off 28. Okay, and I'll put it by ear as well, just so we're all clear. And that is 332 degrees. Okay, so that's that question done there. I'll just do a quick time check. Oh, I've got so much time left, it's unreal. Okay, so number, oh, sorry, yeah, the rest, actually, there's more to the question. I was lucky I checked that, wouldn't it? So the land area covered is 200 kilometers squares and the population is 8,400. No probs. what's the population density of the 3 villages. Remember, the population density, which I'll call PD for short, remember, is the population divided by the area. So this is going to be 8,400 people divided by 200 kilometer squares. Again, you might want to do the old cancel zeros trick, and then 84 over 2 is 42 people per kilometer square. I mean, it does say give your answer in population per kilometer squares, but this is exactly the same thing. Okay, so the populations of these 3 villages are in this ratio. Okay, so 3 to 4 to 5. C for Cwm, A for Althea, and G for Gwyndia. Find the population of Gwyndia. Right, well, the total population is 8,400. Okay, so I've got to share 8,400 in this ratio. Remember the 3 steps? Add, divide, times. 3 add 4 add 5 is 12. And I need to see how many 12s are in 8,400. You can probably see kind of that there's, if you divide it with the bus stop method, all right, you're going to get 700 here. And then times. I'm only going to do 5 times 700 because I only care about Gwyndia. Okay, so 5 times 700 is going to give me 3,500. You could work the other 2 out, but they're not going to mark it. Okay, they only care here about Gwyndia. Okay, time check. Yeah, I can do question 11, I think now. So here we go. All right, so Kingsley invests 3,000 into an account that pays 2% compound interest per annum. Doesn't make any further payments or any withdrawals. How much after 2 years? Obviously, if you had a calculator, you would find your multiplier, wouldn't you? And then raise it to the power of 2. But we haven't got a calculator, okay? So we have to do it the long way. So let's think about the first year. £3,000 is going up. That's what interest means by 2%. Okay? So perhaps you could work out 1% first of all by divided by 100. And you get 30. That means that 2% is £60. So in the first year, you add 3,000. You're going to add on 60. You're going to get £3,060 in the account at the end of the first year. And then in the second year, remember, it gets carried across. This is going up by 2%. So this time, 1%, if you divide by 100, okay, is going to be 30.60. Okay, so if you divide by 100, you're going to get £30.60. And so that means that 2%, if you double this, you're going to get £61.20. So you have to do 3,060 plus £61.20. Whichever method you use, you should get you should get £3,121.20 in the account. 3121.20. Well, obviously, if you had a calculator, all right, then you could just do 3,000 times 1.02 squared, but you would get the exact same answer. Okay, all right. Without a calculator, you got to go the long way. And I'll just finish off part B then. So Kingsley buys a portable speaker, and the speaker's been reduced by 20% in the sale. He pays £72 in the sale. What was the original price? So this question, you should draw a picture, okay, in time order. The original price came first. I don't know where it is. The sale price is £72. And this has gone down by 20%. Okay. Now, remember, the trick here is to think about the decimal again. If it's gone down by 20%, then remember you would do 100%, take off 20%. That's 80%. And if you divide by 100, you get 0.8. That's your multiplier. So this shop's till has done something times by 0.8 is 72. but I need to work backwards and do this multiplying. So I'll have to divide. So 72 divided by 0.8. Make the bottom into 8. By times it by 10. Times the top by 10 as well. You get 720. Get on that bus stop method. And you get £90. Okay? And that question is done. You can always check by doing by finding 20% of 90, which is 18, and take that off, and you would get 72. Question 12. So Michelle owns a cafe. She stacks coffee mugs as shown below. Right, okay, I see. So each coffee mug is 12 centimeters, correct to the nearest centimeter. So I know this is a bounds question straight away. So let me get going. 12 centimeters. It's correct to the nearest centimeter. So it could be as small as 11.5 centimeters, or it could be as big as 12.5 centimeters. Well, I mean, really it's 12.49 recurring in it, but we can't do maths with that, so we call it 12.5. And each stacked mug creates 4 cms extra height, again, correct to the nearest centimeter. So it could be as small as 3.5 or as big as 4.5, no probs. And she knows that the height between the two shelves is exactly 39 centimeters as shown. This is exact. There's no bounds here, no probs. So where's the question then? Over here. Right, so can she be certain she can place one stack of 7 mugs between the two shelves? Give a reason for your answer. Right, well, from the picture, 7 coffee mugs, and it's going to be 1 mug, isn't it? At the bottom, plus 6 stacked mugs. So really, I'm trying to see now, how tall will this stack be? If it's bigger than 39, they won't fit. If it's less than 39, they will. Okay, so think about to be certain, think about the worst case scenario. In the worst case scenario, the mugs will be as big as possible. See, that'll make the biggest possible height. So let's think now, okay, right? The biggest possible height. Well, this will come on it, okay, from adding up the biggest heights of the relevant mugs. I didn't say that the bottom mug could be as big as 12.5 centimeters, okay? That's what it said. So that's the 1 mug. And these 6 mugs, well, it could be as big as 4.5, we said. So leave the 12.5 alone. And then 6 times 4.5. Well, 6 times 4 is 24. Half of 6 is 3. 24 add 3 is 27. So this stack could be as tall as 39.5 centimeters. And that's not good news, is it? Because if it is that big, and it could be, that's taller than 39. So it won't fit. Okay. So we can say we cannot be certain they will fit. And you could be flashier, couldn't you? Since 39.5 is bigger than 39. And that's that one done. Okay, number 13. 50 runners took part in a 5-kilometer race. And the cumulative for each diagram shows the times taken by the runners to finish the race. No problems, I see that yet. What is the modal group? Remember, the modal group, okay, is the most popular group. The group with the most number of people in it. And we can clearly see that this first group, from 20 to 25, see the jump here, from here to here, the jump is much bigger than any other jump. So this first group has got by far the most people in it. Okay, done. Where's the next question? Right, is it certain the last runner's time was 45 minutes? Well, I'm going to say no. You might think it's yes, but remember, we can't be sure because cumulative frequency is all done in groups. See, this first group was 20 to 25, second group 25 to 30, etc. So this last group here only counts the people between 40 and 45. So we could have had people in here, couldn't we, who had 42 minutes, 43 minutes. We don't know if someone definitely had 45. That was just our grouping system. So I'm going to say no. And the reason, okay, we are using group data. Sorry, we are using group data. Okay. The runners hope that 80% of the runs will finish within 30 minutes. Complete the following statements. Percentage of runners finish the race within 30 minutes. Okay, right, so let me go and find 30 minutes then. It's here. If you read across from 30, we hit 35. Right, so remember that's 35 runners out of the 50 runners. So if you've got 35 out of 50, can we see that to make the bottom 100 times by 2, 35 times 2 is 70, so that's 70%. And 80% of the runners finish the race within X minutes. Well, remember, 80% of the runners is 80% of 50, and that's easy to work out. 10% is 5. 40 runners. Sorry, 40 runners. So I will definitely, okay, find the 40 runners. So 40 people's up here, and I will read across, and I will read down, and you actually hit that's 35 minutes. Oh, sorry, where did I go? 40 runners there. So what did I say? It was 35 minutes. Done. Okay, so last year the median time was 26 minutes. How many minutes was it better this year? Remember the median, okay, is halfway through. So there's 50 runners. Half the way across is the 25th runner. But this isn't the median. The median is going to be the 25th runner's time. So if I find the 25th runner, so difficult to count on here, sorry. 1, 2, 3, 4, I think it's here. If you read across and read down, you actually hit 1 square before 25. So you might think that's 24, but you'd be wrong. See, because there's 10 squares here from 20 to 25. So every square is 0.5. So actually this year, okay, is 24.5. 24.5 minutes is this year's median. Okay, so it's 24.5 minutes. I don't see how many minutes was it better than last year. If you just find the difference, you'll see that it's 1.5 minutes bigger. So this year was 1.5 minutes better than last year. The last question then. This one's quite weird. So 2 entrances to a stadium, north and south. I see it. At each entrance, 3,000 people queued to get into the stadium through security. The length of time they spent in the queue was recorded. I see that, yeah. The box plots show the results. No props. Right, so at the north entrance, how many people had to queue for more than 44 minutes? So on this scale, 44 minutes is here. And you might think this question is impossible, but it's not. If you remember that on a box plot, this is the lower quartile, that's the median, and that's the upper quartile. This is the minimum, this is the maximum. Remember, this is at the start of the data. This is 0% through. The lower quartile is a quarter through, or 25%. The median is 50% through, halfway. And the upper quartile is 75% of the way through. And the max is all the way, 100%. So for more than 44 minutes, you can see it's all these people here. And that is 25% of the data. See, from 75% to 100% is 25%. So I will just work out 25%, sorry, of 3,000. So half it and half it again, and you get 750 people. Okay, and then next one, the next question is here. For the south entrance, find an estimate for the people who had to queue between 40 and 60 minutes. So the south entrance, 40 and 60 minutes. Okay, so let me just get a look at this a minute. So this is the lower quartile, median upper quartile. 40 and 60 minutes. Well, here, look, all right. Can we see, look, that this median is 50% of the way through. So there's 1,500 people here up to this point, and the upper quartile is 75% of the way through. So this would be 2,250 people. So hopefully you can see that in this whole section here, there are 750 people. But I don't want all of it, do I? Okay, I only want this bit here. And if you look very closely, you can see that this section here is 2/3 of the whole thing. If you don't believe me, I'll try and show you in blue. See, if I dropped 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, if I dropped here, can you see? There's 3 equal size bits here, okay? 1/3, 1/3, 1/3. So there's 2/3 here. So I'm going to work out 2/3 of 750. Okay, and I should be okay, should be good to go there. So the red pen, all I need is 2/3 of 750. Divide by the bottom, and then times by the top, and you get 500 people. So the last question, at which entrance did the team be more effective at getting people into the stadium quickly? Give a reason. So I was going to check on this one. I was going to check the medians, but when I checked the medians, I was gutted because you can see the medians are both the same value. Okay, they both sort of, I think they both sort of 30. Okay, so the medians won't help us here, but I mean, hopefully you can see kind of that the north entrance, all right, if you compare the upper quartiles, 75% of the people in the north entrance got through in less than 44 minutes. In the south entrance, okay, 75% of the people took an hour to get through. So the north entrance was actually much faster at getting people in. So I will just say, for the last mark, the north entrance, because 75% of people got in under 44 minutes. In the south, it was, well, let me say it took an hour. So this north end is clearly faster at getting people in. So we're done there. Okay, I'll stop. And then thanks for listening, and I'll catch you soon.